Hello guys, and welcome to the Bright Agent. Today we are going to look at the structure of an atom and how all those things inside of it have significance. Be bright, stay right, and I hope you enjoy this video. Make sure you subscribe as it motivates me to post more educational videos like this for more people to learn about. Now first, we're going to look into the atomic structure. Now, as shells, you could just imagine shells as a circle like this. And those shells have electrons located in them. I'm going to talk about shells later, but that's where the electrons are located. Just no confusion. Only electrons, not protons, not neutrons, just electrons are located in the shells. The shells, also called levels in physics, or energy levels, some people may call them. And even if you only have one shell, that's one level. If you have 2, 3 or 4 shells, that's 2, 3 or 4 levels, etc. Now, we're going to move on into the nucleus. The nucleus has protons and neutrons. And I'm going to move on to the question of what is a proton. The proton is a positive subatomic particle, and it has a charge of +1, not -1. Protons are positive since they start with the letter P. That's not exactly how I memorized it, I just really knew it as soon as I was taught about it. But for anyone who's really struggling to remember and desperate to know whether protons are positive or not, protons are positive since they start with the letter P. They have a charge of +1, they have a mass of 1. That is the important part. Not -1 or whatever, since no particle has -1 charge. All things have a positive mass, not negative, not ever negative. It's only when you're losing mass. But then again, the mass is still positive. So protons have one mass of 1. Now, protons are really important since if you're studying elements, for example, if you're looking at things like oxygen, it has an atomic number of 8 and a mass number of 16, but we'll get on to more of that later. Now, that atomic number is very important. If you ever struggle with the atomic number, remember that the atomic number is the number that indicates how many protons there are. So in this case, there would be 8 protons in oxygen. No matter what isotope you may find, which is the differing amount of neutrons in the same element, it would still have the same amount of protons. Important part. Now, we're going to move on to the electron. The electron is located in shells and is negative. It has a negative charge, but not a negative mass. Some people may say that it has a negative mass but not a negative charge, or it has both a negative charge and a negative mass. As was said earlier, there is nothing which has a negative mass. Even if something loses mass, it can only be positive. So electrons, GCSE boards like AQA or Edexcel, as my school is, they mark it as negligible or 1/1835. Some examples say 1835 to 1837, but it's just better to go with negligible if you can't remember the exact fraction. Electrons are very important since, as I said before, atomic number indicates how many protons and electrons there are. And because electrons are negative, That means any element that you find, or almost any, because there are a few random outliers, that means that each element will be neutral, since protons have a +1 charge and electrons have a -1 charge, meaning that each element will be neutral. They will have 0 charge, since a +1 and a -1 cancel each other out. So for anyone who's thinking that atoms are plus or minus, you're confusing that with ions, which aren't totally different, but they are different because it's the loss of electrons which makes them ions. The loss or gain. The loss makes them positive, and so makes them positive ions for things such as aluminium or sodium. Negative ions such as oxygen or chlorine or fluorine, they are negative ions. Negative ions are also known as anions, because in our school they say that onions make you cry, and anions are negative, and crying is a negative experience, which is why we now all remember that anions, or just negative ions, are negative. Now, for those positive ions, cations, because cats meow, cats purr, cats are positive. They are a positive influence, therefore cations are positive. So essentially speaking, those ions which are either positive or negative, because if they're a charge of 0, they're not ions anymore, they're just an element, they are really important to know about. But today we're just focusing on elements. I might elaborate on that on another video. Now, moving on to neutrons, the other subatomic particle apart from the proton, which is located inside the nucleus. Now, the neutron is a neutral subatomic particle. Neutral. Neutron. They all have neutral and neutron. That's how you remember that the neutron has a charge of 0. Like the proton, it has a mass of 1. It doesn't have a mass of 0. Since everything, no matter how small or sub or big, has mass. Even if you're looking at this tennis ball, for example, as small as it may be, it has mass. So that's an example of something having mass. And neutrons are one of the several examples that we have. Now, neutrons are also very important. They are not unimportant. They are not less important as protons and electrons are, since we've seen how they can be relevant in other topics of chemistry. Now, neutrons are important because if you look at isotopes, as I was talking about earlier, isotope is the differing amount of neutrons that are present in the same element. And that element is categorized by the amount of protons it has. For example, if there was one proton element, it would be hydrogen, as we all know. And if there were 26 protons, for example, it would be iron. So the amount of protons will literally show you what type of element it is, as in the name of the element. It just depends on how many protons there are. But if you look at isotopes, they only change in neutrons, and some isotopes can have a smaller amount of neutrons or a greater amount of neutrons, but they are often greater. Now, if you look, example such as hydrogen, like tritium, if you look at examples such as tritium, those will have more neutrons than the standard hydrogen that we have in our periodic tables, and for good reasons. Isotopes aren't located in periodic tables since we make them much longer, but for the sake of this, It's just a different amount of neutrons. Even if you have like 2 different isotopes, 3 different isotopes, or even more than that, as some few elements have, they will still be the same element. They'll have a greater mass number if they have a greater amount of neutrons, but the type of atom that they are will not change. So essentially that's what isotopes are, and that's how neutrons are relevant to it. Now, something very, very, very important. If I had a mass number and an atomic number, let's take oxygen as another example. Oxygen has 16 mass number and 8 atomic number. So what you would do to find the amount of neutrons there are is just do 16 minus 8, or in this case the mass number minus the atomic number. It doesn't matter what the mass number or the atomic number is. If you see a question which says calculate the amount of neutrons there are, or you're in a question where it's 3 or 4 marks, or even 2 marks, or 1 mark, so on and so forth, you could see a question where it requires you to see the amount of neutrons there are on a substance. It isn't very, very hard. All you have to do is do mass number minus atomic number, and there you have it. That's your answer to find out the amount of neutrons there are in an element. Remember that the atomic number isn't the amount of neutrons. It is the amount of protons and electrons. That is very important, because if you get that wrong, if you get the amount of neutrons wrong, then that means you're talking about a completely different element, or possibly one that doesn't even exist, because you could be talking about an amount of neutrons, in rare cases, that aren't present in any atom at all, and therefore you'd be marked wrong in exams. So remember, protons are positive, they have +1, and they have a mass of 1. Neutrons have a charge of 0, and they also have a mass of 1, just like protons. Electrons have a charge of -1, and the mass is either negligible or 1 over 1835. Some people may say, oh, electrons have a mass of 0. In some examples, this is completely fine, since electrons don't really have that much mass anyway to begin with. But other examples see it as completely wrong, since everything has some mass. They have some mass, meaning that they can't possibly have none of it, because if they did, they wouldn't exist. So essentially, I hope that I've made the structure of an atom and the importance of those subatomic particles located in that structure, I hope I have made it easier for you. Be bright and stay right, and I hope you have a good day.